So this is a derivative control demo so this script is being written in Python. So this is the derivative control function. Okay, so we define KD, derivative is 0.2 derivative term, and which is KD gain multiplied by the uh, error minus previous error and divided by uh, the time delay. Okay, so this is the main loop in which we are calling this. We are setting a point as 50, then we have a process variable, then we have previous error, and then time interval for derivative control. So this is the continuous loop. In this continuous loop we are processing the variable equals to slider.get, means that uh, the value of this variable is being captured and then error is being calculated according to that, and then we call this derivative control function which calculates the derivative term and put it into derivative term, and then we calculates. And so what it does is, so when you move the slider from 29 to 30, it gives a negative derivative term uh, uh, which uh, after a few time comes to 0, and if I move to left it becomes positive, and it increases but it again goes to 0. So it does not make your error, make your variable points towards the set point. So in this case 50, like in integral control, it wants to be at 50, but here it wants to be at 27. So if I move it to the left of 27, it gives a negative derivative term uh, which wants to get to uh, uh, again to 27. So if I move to 25 from 30, it wants to move to its initial place. This is uh, this is done so that the if you have a very shaky if you have a very shaky variable that is shaking, oscillating at its initial place, it dampens its value to a finite to a steady value. So it dampens, it absorbs the shock, something like that. So you can use this to make your program more smooth, and this is how you can do it.